So you want to evaluate that function. You had one, that it wasn't this one, but there was one in your final that dealt with this. And you were asked, though, in that final to find f of 3, let's say. That's what you asked to do. Find f of 3. Well, remember, f of 3 means what's the y value in x is 3. And if the graph is given, that's easy to do. We did that earlier today. But the graph is not given. The function is given. The equation is given. But remember, f of x means the same thing as y. F of x means the same thing as y. So this right here means the same thing as this. All right, so remember that discussion last semester. So y is the same thing as f of x, g of x, h of x, whatever it may be, whatever your function notation is. So f of 3 means, remember, 3 takes the place of what letter? X. So f of 3 means wherever you see the x variable, you substitute 3. So that becomes 2 times, in parentheses, x. What's x? What am I doing to this 3? Squaring it. Minus 3 times x. What's x? 3, and then plus 1. Now, you got to remember order of operations. Now, you're in college algebra. I'm hoping that you all realize that you're not going to say 2 times 3 is 6 and then square that, right? Okay. You got to do what first? Square the 3. Remember, you got to do exponents before you multiply. So 3 squared is 9. 9 times 2 is 18. And then minus, what's this? 9 plus 1. Now, remember, you add and subtract from left to right. So don't say 9 plus 1 is 10. Some of you, last semester, you did that, some of you. But you know that's not 9 plus 1 is 10. Because that's really a negative 9 plus 1, right? Okay. So let's go from left to right. What's 18 minus 9? 9, and then 9 plus 1 is 10. So if you had said this first, if you had said 9 plus 1 is 10, what's 18 minus 10? 8. You would have gotten 8 instead of 10. So you need to do it from left to right. Okay, so that's last semester. Now here's what's going to happen now. I'm going to start with a simple one. Suppose that f of x is 5x minus 2. 5x minus 2. And let's suppose, I'm going to do several parts here. I'll call this part A. Let's suppose you want to find f of negative x. F of negative x. All right, well, where we see the variable x, what do I substitute? Not negative 1. That's not negative 1. That's what? Negative x. That's negative x. So where we see the variable x, you substitute what you see inside this parentheses. You substitute negative x. So I get 5 times what? Negative x minus 2. Well, what's 5 times a negative x? Negative 5x minus 2. And those are not like terms, so that's all you can do. So in the blank, you're going to say f of negative x equals what? Negative 5x minus 2. That's what f of negative x equals. So notice that in number 1, you evaluated at a number. You ended up with a number. Here, you're evaluating it at a variable expression. You're going to end up with a variable expression. Part B. Suppose you want to find f of x plus 2. Find f of x plus 2. All right, so remember, f of x is 5x minus 2. That's f of x. So if you need to rewrite f of x, go ahead and do so. And remember, I want to find f of x plus 2. So I'm going to underline x plus 2 here. So wherever we see the variable x in my function f, I'm going to substitute x plus 2. And so when I do that, I'm going to get 5. Now, we've got to be careful. See, I'm substituting in place of x. What am I substituting? X plus 2. That is being multiplied by what? It's being multiplied by 5. So that becomes 5 times in parentheses x plus 2. Because the whole thing, x plus 2, has to be multiplied by 5. So it's not really 5x plus 2, it's 5x plus 10. That's what this is. And then I'm going to subtract what? 2. All right, simplify this. You know you can go further with this. Distribute. I get 5x plus 10 minus 2. And what's the answer? 5x plus 8. So f of x plus 2 is going to equal 5x plus 8. So if f of x is 5x minus 2, then f of x plus 2 will be 5x plus 8. Part C. What if you want to find f of 2x minus 1? All right, now at this point you should now know what to do. All of you should now tell me what to do. I go to my function f of x, which is this, and where we see the variable x, I'm going to substitute what? 2x minus 1. All right, so I'm going to get 5 times, in parentheses, what do I substitute? 2x minus 1 plus 2, right? Oh, I wrote this wrong, didn't I? I'm sorry. That's minus 2. So that's minus 2. You're right. Thank you. Minus 2. All right. The rest you've had before. What's the next step? Distribute. So I get 10x minus 5 minus 2. So what's the answer? 10x minus 7. So f of 2x minus 1 equals 10x minus 7. So if f of x is 5x minus 2, then f of 2x minus 1 is 10x minus 7. Okay? All right. Now, let's look at this one. This is going to be number 3. So number 3, let's suppose in number 3 that g of x is, I'm going to make this one simple for right now, x squared minus 2. So we're going to start with a simple one, then I'm going to do another one that you're most likely to see. Okay, so if g of x is this, then part A, let's find g of negative 2. Now I'm evaluating at a number, so my answer better be a numerical expression, right? So what does that mean to find g of negative 2? Plug in negative 2 for x, okay? Plug in negative 2 for x. And so I get, now remember how some of you write this, you're going to say this. Is that correct how to write this? No. Because if you write like that, mathematically this means negative 4. But that's not negative 4. That's supposed to be a what? Positive 4. So you need what here? Parentheses. So what's negative 2 squared? 4. 4 minus 2 is 2. So g of negative 2 is 2. All right, part B. All right, part B, let's suppose you had this, g of negative x. Now, for some reason, g of negative x throws things off. It should. Where we see the variable x, you substitute negative x. And if you need to, compare to letter A. So I have, remember, g of x is this. I'm going to go ahead and rewrite it. Sometimes it helps if you rewrite it so that way you can kind of like draw this arrow to it. So when I substitute, where we see the variable x, I substitute negative x. Remember, put that in parentheses. So I put negative x in parentheses, and that's being what? Squared minus 2. Now think about what negative x squared means. Negative x squared means what? Negative x times negative x, which is, no, what's negative x times negative x? It's x squared.
Yeah.
Yeah, you said positive x though.
Oh, that's why I have x squared.
Okay, x squared. So what's the answer?
X squared minus 2.
X squared minus 2. There's your answer. So g of negative x is x squared minus 2. All right. Part C. Suppose you want to find g of 3x minus 1. G of 3x minus 1. Where we see the variable x, we substitute 3x minus 1. All right, so no big deal. You dealt with that before. So remember, g of x is this, x squared minus 2. So where we see the variable x, you're going to substitute 3x minus 1. So that's 3x minus 1 in parentheses, but what do I do to that? Square it, and whatever that is, I'm going to subtract 2. Now, don't leave your answer like this. You're expected to multiply this out. So let's go off to the side and figure out what 3x minus 1 squared is. Now, you had that part in Math 98 to get to FOIL, remember?
Yeah.
So don't I have a binomial squared?
Yes.
Well, this binomial squared means the binomial times itself. So let's FOIL. What's 3x times 3x?
9x.
Girl, keep saying that. 9x squared. What's the outer?
Negative 6x.
Negative 3x. What's the inner?
Oh.
Negative 3x. And what's the last? Positive 1. When I combine like terms, what do I get? 9x squared minus 6x plus 1. So what I found was only this part here. So that is 9x squared minus 6x plus 1. But what else do I need to do?
Minus 2.
Subtract 2. And now combining like terms, and you found your expression. So what do I get when I combine like terms?
9x squared
Minus 6x
minus 1.
minus 1. So g of 3x minus 1 is going to equal 9x squared minus 6x minus 1. Now, you need to be practicing with this idea because there is something important, especially if you're going to take business calculus.
What?
That's called the difference quotient. So at some point, either next week or the week after, we're going to be finding f of x plus h. So we have an x and an h.
That's comforting.
It is. All right. So let's look at D. All right, D. Suppose you want to find g of 2x plus 1. All right, now, let's see how far you can get in about 1 minute. Now, you're not going to get it done in 1 minute, but let's see how far you can get in 1 minute.
2.
I'm sorry?
It's 2. Minus 2.
Oh, I'm doing the wrong one. I'm sorry. Thank you. All right. So where we see the variable x, I substitute 2x plus 1, right? Okay. So I'm going to get equal, in parentheses, 2x plus 1 squared minus 2. Y'all agree? So let's go off to the side and kind of deal with this part here. So 2x plus 1 squared means 2x plus 1 times itself. So I got to multiply this out. Well, that's two binomials, so I know I can use a FOIL method on that. So 2x times 2x is 4x squared. The outer is 2x. The inner is 2x. And then plus 1. Combine like terms, what do I get? 4x squared plus 4x plus 1. Now remember, that's just this part right here. So that's 4x squared plus 4x plus 1, but I got to subtract 2. So therefore, g of 2x plus 1 is going to equal what? 4x squared plus 4x minus 1. Okay? All right, let's do number 4. Number 4. Suppose in number 4, I had this. H of x is 3x squared minus 5x minus 2. So h of x is 3x squared minus 5x minus 2. So from last semester, let's suppose you want to find h of negative 2, let's say. What would you do? Where we see the variable x, you'd substitute negative 2. And I see x listed twice on this side. So I get 3 times in parentheses negative 2 squared minus 5 times negative 2 minus 2. That's what I get. That's the first thing you should do, is substitute what you have. Then the rest is using the order of operations. Please excuse my appearance out. So again, our discussion earlier, you're not going to say 3 times negative 2. You're going to do what first? You're going to square first. What's negative 2 times itself? 4 times 3? 12. All right, so I get 12. What is this right here? Plus 10. Good. And then minus 2. All right, let's go from left to right. What's 12 plus 10? And what's 22 minus 2? 20. So h of negative 2 equals blank. What goes in the blank? 20. So basically, if you were to graph this, and by the way, what would the graph look like if you were to graph this? And you will soon have to graph something like this. What does a graph of this look like? The parabola.
Yep, parabola.
You have x squared. Y equal y to the first. Remember, h of x is y. Y to the first, x squared. So basically, you just found a point on the parabola. When x is negative 2, what's my y coordinate? 20. So if you were to graph this, that point would be on the graph. Part B. All right, now this is the one that's going to take a while because you have 2 terms with variables. See, in number 3, when you did number 3, how many terms had variables? Just 1. Here, how many terms had variables? 2. All right, so let's find h of 2x minus 3. H of 2x minus 3. All right. Make sure you do them in steps so that way you don't mess up. So this says, and remember my function is h of x, so h of x is 3x squared minus 5x minus 2. So where we see the variable x in my function h, what do I substitute? 2x minus 3. And I see it twice. So the first thing you should all do is say 3 times in parentheses, what do you say? 2x minus 3. And what do I do to that squared? And then I say minus 5 times in parentheses, what should you say? 2x minus 3, and then minus 2. So all of you should have this written down. No one should not have this written down. That should be written down on your worksheet. Now the rest is where you have to go off to the side and do some stuff. Like really the thing that you have to do off to the side is this binomial squared. So you got to go off to the side. So I'm going to go off right here. And then kind of figure out what 2x minus 3 times itself is. Well, what do I do? FOIL. So 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. The outer is negative 6x. The inner is also negative 6x. And what's the last? Plus 9. When I combine my like terms, I get 4x squared minus 12x plus 9. Now remember, all I found was only this part here, so keep that in mind. That's all I found was this part here. But all of this has to also be multiplied by 3. So now what you're going to do is you're going to go right under here. You're going to say 3 times in parentheses. You're going to write the trinomial. What's the trinomial? 4x squared minus 12x plus 9. Now at that point, you can go ahead and distribute this now. So if I distribute this, what do I get? Negative 10x plus 15 minus 2. Couple more steps and you're done. Now the next step is to distribute this now. What do you get?
12x squared
12x squared
minus 36x
minus 36x
plus 27.
plus 27. I'm writing everything else over. That's all I'm doing. So notice the steps, not difficult. And then finally, the last thing you do is what? Combine like terms. And so therefore, h of 2x minus 3 is going to equal 12x squared. Okay, what's a negative 36x and a negative 10x? Negative 46x. What's 27, 15, and a negative 2? 40? Okay, so there's your answer. So h of 2x minus 3 is 12x squared minus 4x plus 40. Yes?
So if that could be, not saying this one, but if it could be simplified, would you go further?
What do you mean by simplify?
Like,
Or GCF or something?
No. Don't factor.
okay.
You leave it. Yeah. So if you're asking, can you factor? No. Leave it like that. Leave it as a polynomial. Yeah. Leave it as a polynomial. All right. C. Let's do one more with that. So let's suppose you want to find h of 5 minus 2x. H of 5 minus 2x. So where we see the variable x, what do you substitute? Yeah, so I'm going to go ahead and just rewrite h of x. So h of x was 3x squared minus 5x minus 2. So where we see the variable x, I'm going to substitute 5 minus 2x. And so I get 3 times in parentheses. What do I write? 5 minus 2x. What do I do to that? Square it. Minus 5 times x. What's x? 5 minus 2x. And then what? Minus 2. All right, what's the next step? Yeah, you take that binomial squared and you FOIL it out. So 5 minus 2x times itself, right? What's 5 times 5?
25.
What's the outer?
Negative 10x.
And the inner should also be the same because you're squaring a binomial, so it should also be what? Negative 10x. And then what's a negative 2x times a negative 2x?
Positive 4x squared.
Positive 4x squared. Combine like terms, you get 25
Minus 20.
minus 20x
Plus 4x squared.
plus 4x squared. So all I found, though, you got to be careful. You got to remember what is that you just found.
Just the binomial.
I just found that binomial square. That's all I found was this little part here. But that trinomial has to also be multiplied by 3. So you got to keep that in mind. So you're going to say 3 times this trinomial, 25 minus 20x plus 4x squared. And then let's go ahead and distribute the negative 5 here. I get
Positive.
negative 25 plus 10x, and then minus 2. Okay, you want to leave your answer like this?
No.
No, if you do, you're not going to get full credit. What should you do next? Distribute. So I get 3 times 25 is 75. 3 times the negative 20x is negative 60x. 3 times 4x squared is 12x squared. And then just rewrite everything else over. And now, what's the next step? No, we already distributed.
Oh, and
Combine like terms. So therefore, h of 5 minus 2x is going to equal, and what would that equal?
12x squared.
Now, let's go ahead and put it in descending order. So you're going to say 12x squared
Minus 50x.
minus 50x. A negative 60x and a positive 10x is a negative 50x. Now, what about your constant? 75 and a negative 25 and a negative 2.
48.
Positive 48?
Yeah.
All right, so there's your answer. Okay. All right, let's do one with an absolute value because there's one like that on your worksheet. So let's just do one like that. So this can be number 5. Sorry, number 5. So let's start with a simple one. So let's say f of x is the absolute value of 2x minus 3. So f of x is the absolute value of 2x minus 3. All right, now, part A, let's find f of negative 3. All right, so remember, when I evaluate at a number, I'm going to end up with a number as my answer. I won't have any variables. So again, that means wherever you see the variable x, what do you substitute? Negative 3. So I'm going to get the absolute value of 2 times negative 3. Whatever that is, I've got to subtract 3, right? Okay. So let's work within the absolute value bars. What's 2 times a negative 3? Negative 6. And look at what I have. I have the absolute value of negative 6 and negative 3, which is the absolute value of negative 9. And you all know that absolute value of negative 9 is just 9. So f of negative 3 is just 9. Don't say the absolute value of 9. You got to say what? 9. Okay? Okay, now, part B. What if you want to find f of x plus 1? Now, this is going to get some of you in terms of what the answer looks like. F of x plus 1. So I'm going to go ahead and rewrite this over. So here's my function. So again, wherever you see the variable x, what do I substitute? X plus 1. All right, now remember that's absolute value bars. Don't confuse that. Don't confuse that with something like this. Those are not the same function. This is a linear function. This is an absolute value function. All right, so the way we write it, don't confuse it with something that's linear. Those are different. So I get f of x plus 1 will equal the absolute value of 2 times, in parentheses, what do I substitute? X plus 1. Whatever that is, I'm going to subtract 3. Okay? Distribute. I get the absolute value of 2x plus 2 minus 3. Simplify what's in the absolute value bars. I get the absolute value of 2x minus 1. Now that's where I'm at. Okay? When we did letter A, my answer did not have an absolute value bar in it, right? Because we know that the absolute value of negative 9 is positive 9. So I was evaluating the absolute value at a number, so I know I would end up with the positive part of it. But here you're evaluating a variable expression here. You're taking the absolute value of the variable expression. So don't say the answer is 2x minus 1. Don't say, this is incorrect. Don't say this, because that's not true. Don't say this either, because some of you like to take the absolute value of negative 1, but it's not. See, this is what? Positive 1. But that's not by itself. What else is attached with this negative 1? 2x. So you cannot say that that's going to be 2x plus 1. That's not true. So when dealing with absolute value, there's a variable expression inside. Leave it as it is. Leave it as it is. So the answer will be what you see. So leave it as the absolute value of 2x minus 1. Okay? So if you're evaluating at a number, if you're evaluating an absolute value at a number, you're going to end up with your answer not having an absolute value bar, because you know the absolute value of negative 9 is just 9. That you know. But you cannot say that the absolute value of 2x minus 1 is any of these. That's not true. Okay? So you got to leave an absolute value bars, only for the reason that you have a variable expression. Because see, if you left it off, let's say you wrote it like this. I'm going to show you why this is incorrect right here. Let's suppose you said this. Okay? Let's suppose you said it's that. All right. I'm going to ask you this. For this one here, so you're telling me if you write this, you're saying that the absolute value 2x minus 1 means the same thing as this. Okay? That's what you're saying. So let's suppose I want to find, so you're saying these two are equal. You're saying 2x minus 1 and the absolute value 2x minus 1 are equal. So if I substitute 3, what's 2 times 3? 6. What's 6 minus 1? Okay, so when x is 3, I get 5, right? All right. When x is 3, what's 2 times 3? 6. 6 minus 1 is 5. Absolute value of 5 is 5. Okay? No big deal yet, but what about if I had this? What about if I substituted x equal negative 3? What's 2 times negative 3? Negative 6. Negative 6 minus 1? Negative 7. So I get negative 7. What's 2 times negative 3? Negative 6 minus 1? But what's the absolute value of negative 7? 7. Those are not equal. All right. So when you evaluate an absolute value expression, leave the absolute value bars. You just can't take them off because what you have is not necessarily true. Sometimes it's true, sometimes it's not true. Okay, so that's something you have to remember. So now, let's look at something like number 3. Let's look at number 3, something like that. So this is going to be number 6. Let's suppose you had k of x is the absolute value of 3x minus 2 divided by x plus 5. So k of x is the absolute value of 3x minus 2 divided by x plus 5. Part A, let's find k of negative 2. K of negative 2. What does that mean? Where we see the variable x, what else substitute? Negative 2. All right, so I get, in the numerator, I get the absolute value of 3 times x. What's x? Negative 2. Whatever that is, I've got to subtract 2, and then whatever that is, I've got to take the absolute value of that. The denominator does mean negative 2 plus 5. Okay? All right, so let's go further. Let's go to the numerator again. What's 3 times negative 2? Negative 6. What's a negative 6 and a negative 2? Negative 8. So right now, all I have so far is this. I have the absolute value of a negative 8, right? Divided by what? 3. Now you know you don't leave it like this because you all know that the absolute value of a negative 8 is 8. So the answer should be what? 8/3. Because you know how to evaluate an absolute value of a number. Now look at B. Suppose you want to find k of x plus 2. K of x plus 2. All right, wherever you see the variable x, what do you substitute? X plus 2. All right, so I'm going to go ahead and rewrite k of x. So it's this, absolute value 3x minus 2 divided by x plus 5. So wherever you see the variable x, I'm going to substitute x plus 2. So I see it twice on this side. One, the numerator involves absolute value. The denominator does not. So my numerator, I'm going to have absolute value of 3 times in parentheses, what do I put? X plus 2. What else must I do within the absolute value bars? Minus 2. Now let's go to the denominator. The denominator, what do I substitute for x? But I also add what? 5. Okay. My denominator is easy. What's my denominator going to be? X plus 2 plus 5. X plus 7. All right, let's talk about the numerator. All right, so the numerator, I'm going to go ahead and distribute. Don't forget, you still have absolute value bars. Don't throw those away. 3x plus 6 minus 2. And then now you know your answer. What do I write? Absolute value of what? 3x plus 4 divided by x plus 7. You know you can't remove the absolute value bars based on our discussion earlier. You cannot say that's the same thing as 3x plus 4. You cannot do that. Because if x is negative 2, if you say the absolute value of 3x plus 4 equals 3x plus 4, if you say that, what you're saying is this. If x is negative 2, then those two sides better be equal. What's 3 times negative 2? Negative 6. What's negative 6 plus 4? Negative 2. What's absolute value of negative 2? 2. What's 3 times negative 2? Negative 6. Negative 6 plus 4? Negative 2. Is 2 equal to a negative 2? No. So you do not rewrite the numerator without the absolute value bar. Leave the absolute value bars there for that reason. Because that's not true. Okay? Because it depends on if x is negative or positive. Okay, so that's your answer. So when you do part 3, 3b, it's going to look just like 3b, like 6b. Okay? All right. Now let's look at the one with the square root. The square root. So let's look at 7. Okay, so let's suppose that f of x is the square root of 3x minus 2 plus 5. Just like this. 3x minus 2 plus 5. And you want to find a f of, let's say, 5. F of 5. So where we see the variable x, what do you substitute? 5. Okay, so I'm going to get, where is the variable x, and substitute 5. So I get the square root of 3 times 5 minus 2 plus 5, right? Mm-hmm. Let's simplify the radicand. Remember, the radicand is the expression that's under the square root symbol, under the radical. 3 times 5? 15 minus 2? 13. So I get the square root of 13 plus 5. Y'all agree? Mm-hmm. Can you do anything else to that? No, don't say that's a square root of 18. You know that's not the square root of 18. Those are not like terms. You can't combine those. Don't say that's also 5 times the square root of 18, because that's not true. Because that's not 5 times the square root of 18. That's 5 plus the square root of 13 plus 5. That's your answer. Leave it like that. Part B. F of 3x minus 1. F of 3x minus 1. So we're going to write this over. F of x is the square root of 3x minus 2 plus 5. So we see the variable x, what do you substitute? 3x minus 1. So I get the square root of 3 times in parentheses, what do I substitute? 3x minus 1, whatever that is, I've got to subtract 2, and then I've got to add 5. Okay? Mm-hmm. All right, let's work within the with the radicand. What do I need to do with the radicand? Distribute. Good. So 3 times 3x minus 1. So what do I get? The square root of 9x minus 3 minus 2 plus 5 on the outside. And then your answer, so f of 3x minus 1 is going to be the square root of 9x minus 5 plus 5. That's all you can do. Don't say negative 5 plus 5 is 0 and say the answer is the square root of 9x. That's not true, because that is not negative 5 plus 0. Negative 5 is down on the outside. Where's negative 5 located? On the radical. So that's all you can do. Okay? All right, so those 7 problems should be enough to where you can do part 2. Part 2. Now look at number 5. Look at number 5. Number 5, remember we did earlier in class? The back page? So from the graph you read the information. So you should all be able to do letters A through F, right? Based on our discussion earlier. Okay. Now let's look at something like G and H. G and H. All right, G and H. Okay, listen carefully to this. I'm going to go back to our handout we had earlier. Our handout we had earlier. And I want you to take out this one. Take out that one, the one we were working on earlier. Beginning of class. Look at the first one. So I'm going to do something like G and H with number 1. So let's go back to this one. And so here's the idea. For what values of x is f of x, and let's assume this is function f of x here. For what values of x is f of x equal to 7? And so I'm going to have blank, x equal blank. Okay? Now, don't confuse that idea with something you had earlier today. Earlier today, you were asked to find f of, let's say, 3. Find f of 3. Well, all of you should be able to tell me what f of 3 is in this case. What's f of 3? 1. Good. F of 3 is 1. So basically, if you take your ruler, it helps if you have an instrument in front of you. So you take your ruler. And so remember, f of 3 means what's the y coordinate when x is what? 3. So here's where x is 3 on the x-axis. So when x is 3, I get this point here. If I label that point, I get the point 3, comma 1. So what's f of 3? 1. So that's what we talked about earlier. Okay, now let's go to this one. For what values of x is f of x equal to 7? Well, remember, f of x equals 7. What does f of x also mean? Y. F of x also means y. So look at what we did here. Here, what was x? 3. And so I was asking, what's the y value? So when I used my ruler, I went along the x-axis. And I said, when x is 3, I get this point, and what's my y value? 1. Okay? Here, I'm saying, what is x when y is 7? Well, I'm going to go along the y-axis. See, y is 7 here, right? So if I go along the y-axis, how many points on that graph? 2. There's this point here and this point here. And I'm hoping you see that if I label those points, in both cases, what is my y value? 7. What's this? What are the coordinates of this point right here? 6, 7? And what are the coordinates of this point? 0, 7. Good. So now you can answer the question. For what values of x is y equal to 7? How many are there? 2. What are they? 0 and 6. So all you do is say x equals 0, comma 6. Don't put that in parentheses, because if you put that in parentheses, it denotes that that's a point. 0, 6 is not to represent a point. So just say 0, 6. Okay? 0, 6. So let's go to another one before we stop with this part. So let's look at, I got to find one that's a function. So I can't use number 2. I can't use the circle because it's not a function. Let me find one that's easy to figure out. Okay, we can go to the absolute value one, this one. So go to that one. Let's do the same thing. Okay, for what values of x is, and let's call this g of x, is g of x equal to, and let's say -2. I'm just wondering how many of you right away, within 5 seconds to 10 seconds, can tell me what x is without saying anything loudly. For what values of x is g of x equal to -2?
Do you want to say it?
Huh?
Do you want to say it or no?
No, write it down. Write it down. Okay, you should all have it by now. On the first 2 rows, what y'all get? -84 is what they're saying. Last 2 rows? -8 and 4. First 2 rows?
-4.
-84. Last 2 rows. If I think -84 is correct, is y'all saying that? No, y'all are correct. So it's -84. Because if you use your ruler, these things do help sometimes, not just for graphing. So remember, this means that y is what? -2. Well, let's go along the y-axis. Here's where y is -2. Y'all see you get 2 points in the graph where y is -2? Right here. So if you label the point, that is 4, -2, and this is -8, -2. So remember, what is the value of x when y is -2? Well, my value of x is what? 4. And that what's the other one? -8. So 4, -8. All right, so that should take care of worksheet number 2. Remember, worksheet number 2, though, is the front and the back. So get that. That's the front and the back. All right, so let's go ahead and take 5 minutes. Just quickly go to the restroom. We're not done. Just do what you got to do.